Today we are going to use synthetic division to divide polynomials. Some people refer to this as a shortcut for dividing polynomials. The first thing that you need to know is the whole placeholder thing, like the ghost term that we talked about yesterday. Make sure the polynomial is in standard form with placeholders. Another term for those placeholders are the ghost terms. And this only matters if it's in the middle. So if you start with x to the third, you need to have an x to the third term, an x squared term, an x term, and then a number. If you start with x squared, it doesn't matter that you don't have the x to the third because there just isn't one. What matters is if there's something in the middle that's missing. And I would go through these steps, but it's really not going to make any sense until you've seen a problem. So let's just turn to the next page and dive right in and do synthetic division. Okay, x to the third minus x squared minus 2x plus 8 divided by x minus 1. Synthetic division deals with the coefficients. So you need to make sure you know what the coefficients are. This is 1x to the third minus 1x squared minus 2x plus 8. The coefficients are 1, -1, -2, and 8. Synthetic division takes the variables completely out of the picture and only focuses on the numbers. So over here on the right side of your paper, write those coefficients. 1, -1, -2, and 8. Synthetic division looks different than regular division. Instead of the division bar going up and over these numbers, we're actually going to take it down and underneath. Leave space underneath those numbers to write another row of numbers. This is going to look really, really weird until we get to the end. Okay, we need to put a number right here. That number comes from the divisor x minus 1. You have to set x minus 1 equal to 0 and solve it. What would x be if x minus 1 equaled 0? 1, which is basically the opposite of the number in that binomial. So that's the number that goes outside of the synthetic division bar thingy. Okay. Are you paying attention? Okay. Synthetic division uses a repeated pattern of multiplication and addition to crunch through the coefficients. Your first step is simply to drop this first number straight down. We have to have a number at the bottom, so drop that 1 straight down. Always take that first number and drop it straight down. The number on the outside is multiplied to the numbers on the bottom. And the answers are written up in this next space. So 1 times 1 is 1. Write that underneath the next number. Synthetic division uses multiplication and addition. Once you get that number there, we are going to add straight down. What is -1 plus 1? 0. Now we're going to do that sequence again. The number on the outside times the number on the bottom. What is 1 times 0? 0. That number is written in the next space. Then add straight down. So you're multiplying and then adding. Multiplying and then adding. What is -2 plus 0? -2. Now we're going to multiply again. The outside number 1 times -2. -2. Then we add straight down. What is 8 plus -2? 6. Put a box around 6. Okay. Now, does that seem pretty easy if you know the pattern? All right. Here's how the answer is formatted. I started with x to the third. your answer is always going to be one exponent less than your biggest exponent. So I'm going to start with x squared. This 1 at the bottom means 1x squared. The 0 means plus 0x. Then your minus 2. The 6 is the remainder, so we put plus 6 over the original divisor, x minus 1. And that is our answer. It is perfectly normal at this stage to be looking at this synthetic division and thinking, oh my gosh, what just happened? Let's do this again, but the one thing that I want to mention is this term 0x, is it necessary to write that? No. Now, some of you really like to write that because you like to account for everything that's in the problem. If you want to account for everything in the problem in your answer, please write that term. If you would prefer to not write 0x, you don't have to write it. Okay, let's do the next one. First thing you need to look for is, are there any missing terms? There are not. So we write our coefficients in the synthetic division problem. This is a 1x to the third, so 1, 2, negative 6, negative 9. Okay, the most common mistake is getting the correct number right here. You have to take the opposite of whatever is in the divisor. So it says minus 2 in the divisor, so we use positive 2. Okay, step 1, drop the first coefficient straight down. You have to have a starting point. That's the first thing that you do. Drop that number. Now you can do the multiplication addition cycle. 2 times 1 is 2. Then we add straight down to get 4. Multiply again. 2 times 4 is 8. Add the numbers straight down. What is 8 plus negative 6? 2. Now multiply. 2 times 2 is 4. And then add straight down and box that last thing. That last number is your divisor. Sorry, it's the remainder. Not the divisor. It's the remainder. That last number is the remainder. The last number is the remainder. The last number is the remainder. The last number is the remainder. Your answer starts with an exponent 1 less than the original. So this 1, this coefficient of 1 is 1x squared plus 4x plus 2, and our remainder is negative 5. We write that as minus 5 over the original divisor. In number 3, there is a missing term. Between 2x to the third and 12x, you need to put a 0x squared. If you forget that 0, it will royally screw up the entire problem and it will not be correct. So for synthetic division, your coefficients are 2, 0, 12, negative 7. What number goes outside of this synthetic division? Negative 6. Now give this one a try on your own. You start by dropping the 2 straight down. And I tried to do some color coding in here, so if you are a color coding type of a person and you want to look at this kind of closely, so the blue is multiplying the outer term negative 6 times the bottom and then writing that up in this row. So negative 6 times 2 is negative 12. In green, I then added straight down to get negative 12. Negative 6 times negative 12 is 72, and then you add to get 84. Negative 6 times 84 is negative 504, and then you add to get negative 511. Now your answer, because we started with x to the third, our first term is going to be x squared. So this first coefficient goes in front of the x squared term. Then negative 12x plus 84, and your remainder is negative 511. So minus 511 over x plus 6. So the really interesting use of synthetic division is how you can use synthetic division to evaluate a polynomial. I have given you problems like this on several tests, and a lot of you still get them wrong because there are so many opportunities to make mistakes when you are plugging negative 3 into this polynomial. So we could do 5 parentheses negative 3 to the third minus parentheses negative 3 squared plus 13 parentheses negative 3 plus 29. Or we can use synthetic division. Are there any missing terms in here? Third, second, x. Nope, no missing terms. So our coefficients are 5, negative 1, 13, 29. We don't have a divisor this time. So the number that goes outside of the synthetic division is the number that we are plugging in, negative 3. We are plugging in negative 3 and using synthetic division to evaluate. We follow the exact same process we did before. Drop your 5 straight down. Negative 3 times 5 is negative 15. And add them together, and we get negative 16. Now this is where I need the help of someone with a calculator because I can't do this kind of multiplication in my head. Negative 3 times negative 16 is positive 48. 48 and 13 added together. Is it 61? Negative 3 times 61. Negative what? And then 29 plus a negative 183 is okay. The remainder of the synthetic division, when you're using it for evaluation, the remainder is your answer. So the function f, when we plug negative 3 into it, we get an answer of negative 154. Okay, here in the calculator, I plugged in this exact polynomial with parentheses around everywhere that there's an x, sticking a negative 3 in there, and the calculator tells me the answer is, should be negative 154. I entered something wrong.